I guess I have two interests. One is in tinkering and building things, and two is in healthcare. I really feel that health and medicine is something that unites everybody, whether we like it or not. We are all patients at one point, and we all experience both the benefits of modern medicine as well as what is lacking. And so, really, what drove my interest into in the field of biomedical engineering is this want to be able to improve healthcare, improve the way we diagnose and treat disease, specifically by building new technologies to do that. So my name is Khalil Ramadi. I'm an assistant professor of bioengineering at NYU Canada and NYU Abu Dhabi. My lab focuses on neuroengineering and translational medicine. So really what we're trying to do is develop new technologies that we can use to interface with the nervous system to be able to treat different kinds of diseases. I'll tell you about one of the recent projects that we've had that has been really cool to sort of see through and hopefully continue to see it grow. We developed a new kind of ingestible electronic pill. And so if you think about pills or capsules that we take, they generally contain drugs. We swallow them and these drugs are absorbed into the body. But there are so many other things in our gut that we can target as well. And from the neuroengineering side, the gut has the second largest number of neurons in our body after our brain. And so what that means is that if we can actually latch onto these neurons in the gut, then we can change different types of neural signaling, different types of hormonal signaling without ever having to go into the brain. And so what these pills do essentially is deliver little micro impulses of electricity to these neurons along the gut after you swallow them that perform some function to be able to modulate hunger, for example. And then when you're done, we excrete them out. So they're never really uptaken and they're not really invasive either. Yeah, it's a really kind of a wild idea. I spent many years before sort of getting interested in the gut developing brain implants. So, think Neuralink, right? These are implants that you can put in through a hole in the skull and leave there for months to years. And we do this for a lot of patients, right? So, for example, patients with Parkinson's disease, one of the best therapies we have to relieve motor symptoms is deep brain stimulation. So electrodes that are probably the size of chopsticks are implanted into the brain and left there for like a decade. But what I kept hearing from patients and clinicians when working on sort of the next generation of these implants is no matter how small you make them, no matter how flexible they are, at the end of the day, they still need to go in through a hole in the skull. And that, practically speaking, is something that people don't want to do unless they absolutely have to. And so this idea turned into, well, how can we modulate the brain without ever having to go into it? And this is where the gut came up, because we realized that there was this wealth of opportunity where these neurons exist, but we don't really have any reliable way to interface with them, even though we can actually do so orally, essentially. So I will say that there's a lot of people involved with research, right? And you have everything from students rotating in lab, graduate students that are really, learning to become independent, postdocs that are, essentially leading their own projects to a certain extent, and then professors that are involved with a lot of these different steps as needed. So for better or for worse, I haven't picked up a pipette in a few years. But I think really the joys of research are in, one, mentoring people. And I really think that we are lucky in a university setting to be able to have this constant influx of young blood looking to learn, looking to be mentored, and being able to try to provide mentorship to them. Two, and this is probably my most fun part of the day, is hearing updates from experiments and what's going on and brainstorming new approaches to either solve problems or think about the next steps. And then the reality of a lot of being in academia is you write a lot. You read a lot and you write a lot. And so you read a lot about what other people are working on and what they're publishing on, and you write a lot in terms of distributing our own work and also applying for grants to support some of the work. Creativity is really important. And honestly, brainstorming is a perfect example for it. I get excited when I learn about problems. So, even if it's like a field that is not exactly one we're working on in lab already, when I pick up a paper and learn something new about how something is done, and it doesn't really seem like it's the best way to do things. I get excited about thinking about other ways that we should improve it. And God knows that has taken us down tangents in the past for people in lab. I think creativity, people think about creativity as being the craziest idea out there. I actually think it's quite simpler than that. I think creativity is being able to take a complex issue, distill it down to the simplest possible form, and then improving it slightly. And if you can do that and either improve someone's life, health outcomes, decrease costs, I would say that is a really creative process. Teaching people design, it's kind of like cheating. I don't do any teaching. I just enable people to discover it by themselves. And that's really, I think, like everyone that fundamentally is a creative person, we are all used to solving our own problems, to innovating every day of our lives. And all you need to do is be able to unlock that so that people are constantly on, as opposed to most of the time what we do is turn it off. And I think part of the design, invent and innovate course is to teach people how to spot problems, and hopefully to get them as excited as I do when they see them. I think people appreciate that scientific research is creative when you show them outcomes. And this is something that perhaps we in the research world need to do better, is this make the research that we do accessible to the general public and then also relevant to them. And there's a time and place for research that uncovers the role of one specific molecule in one specific cell and what it does in cancer. But unless you take that and link it towards a new drug, for example, that can take advantage of that molecular pathway in cancer, then people really don't see the benefit of it. And so I think it's a fine line, because at the end of the day, science is highly specialized. We're becoming more highly specialized. And so teaching people the creativity or showing them the creativity, I think at least, is based on outcomes. And if you're able to show results or improvements or new solutions, I think that, to me, shows creativity.